Lesson 6-2. We are continuing with systems of equations. Remember, a system of equations is two or more equations, and the solution for a system of equations is the point that they have in common. The first way to solve these that we learned in 6-1 is to graph, but as we discussed in that section, that's a little inaccurate sometimes. So in 6-2, we're going to learn how to solve these through substitution. Let's start with getting the vocabulary written down. Substitution method, the most useful definition is right here, solving systems of equations by solving one equation for one variable and then using that information in another equation. I also made the note up here, substitution method is a more accurate process for solving systems of linear equations. For example, let's take a look at problem number 1. I am on page 368, and for problem 1, they give you, naturally, two very simple equations to work with. Here's your system. Here are your two equations. Notice that this one is already solved for y. Y equals 3x. So, you can substitute 3x in your second equation everywhere you see y. So here's the process. X plus y equals negative 32. But we know that y equals 3x. So x plus 3x also equals 32. And now you can simplify. 4x equals 32. And you end up with x equals negative 8. But we're not quite finished yet. What's next, you ask? Well, put negative 8 in either equation, your choice, and figure out what y is. So if y is equal to 3 times negative 8, but if if y is equal to 3 times x, but if x is equal to negative 8, then y is equal to negative 24. And now we are nearly done. You just need to write your answer in the correct format, which is like 2 points that you're going to graph, x comma y. Negative 8 comma negative 24. It does say to check by substituting this in. That is your option in case you want to be certain that your answer is right. It's not essential like it was in solving systems using graphing. Got it. Number 1 on the top of page 369. Here are your two equations. There's your system of equations. You'll notice that actually they're both already solved for y. So think about which one's going to be easier to substitute into the other and see what answer you come up with. Checking your answer, like I said, is optional. Go ahead, work on this, come back and see me when you've got it done. Okay, I think most of what you need I've already written out here, so I will do minimal talking. Understand this step. It was y. It became x minus 1 because we are substituting. So you could check your work no matter which one you used. So you would have started with one of these, and it should look like this. Oh my goodness. Same answer no matter which one you used. problem 2 is adding a step. Here's the system of equations they give you. Neither one is solved for x or y already. So you have to think it through, pick a variable, pick an equation, and solve it for one of those variables. Then substitute. Let's see how they go through this in the book. I would have chosen this one too, just because it has a y without any coefficients, so it's very easy to just move the negative 2x to the other side. Now you have something you can substitute in for. Write out the first equation. This is actually an important step so that you don't get lost in your math, and so I can see what you're doing as you try to do these problems. Substitute in, solve for x, but you're not done yet. Put 2.3 in either equation, solve for y. Now you're done. So got it, number 2. What is the solution to this system? And you need to substitute. See what you can do. Then come back and check with me. Again, I don't know how much talking I need to do because it's all written out here. Here's the system. Think about it. There's one variable without a coefficient over here. Go with that one. Use these gifts while you have them. They won't last. What x is, use it. Negative 43/9 is an ugly fraction, isn't it? Oh well. This is your final answer. When they're looking for a solution of a system, I should have an ordered pair as the answer. So now that you can substitute, let's see if we can find a practical application for this. For example, imagine that you are running a snack bar, and your snack bar sells 2 sizes of snack packs. A big one is $5, and a small one is $3. In one day, you sold 60 snack packs and earned $220. How many small packs did you sell? Now, if you needed this information, I would kind of expect you were keeping track of it as you sold things during the day. But on the off chance that you didn't, you have the tool of algebra to help you figure it out. So first we have to create a system of equations. What do we know? Let's pick our variables. We're going to have x be the large $5 snack packs, y is the small ones. We know that we sold 60 altogether. So x number of large snack packs plus y number of small snack packs has to equal 60. We also know that the large ones cost $5, the small ones cost $3, and in total we made $220. So 5x plus 3y equals 220. And now that you have this, you are ready to go. Because I know you've all noticed there are no coefficients in this equation, so it's easy to solve for either x or y. Take your pick. Then you can start substituting. And here they go. Da-da, da-da-da. It's better when I use their music and not sing for myself, huh? this one, they give you the solution for the system, 20, 40, but they also asked a specific question. How many small packs did the snack bar sell? So make sure you specify that as well. Next, got it number 3. Ooh, video games. You pay $22 to rent 6 video games. There are the charges for new games, charges for the older games. How many new games did you rent? You give it a shot. I'll be here when you're done. So, problem 4 we're just going to talk through. We're not going to do too much work on because it's been pointed out to me by someone whom I will not name. If they're doing 2 topics, systems with infinitely many solutions or no solution, and they ask you 2 questions, one of them is infinitely many and one of them is no solution, and you can either think it through or you can guess. I'd rather teach you the main points so that you can answer this on a test. Basically, when you are, take a look at A over here, when you are working through one of these systems, and say you substitute in, and you end up with a situation like this, negative 7y plus 14 plus 7y equals 14. The positive 7y and the negative 7y cancel out. You're left with 14 equals 14. This means that any number you put in will work, so the system has infinitely many solutions. On the other hand, if you are working through a system of equations, and you do your substitution, and you end up with a situation like this, where, in this case, 3x and negative 3x cancel out, and you're left with negative 11 equals negative 13, which you know is not right, that means this system has no solution. I wonder why a system might have no solution. Can you remember? So this is normally where I would say do got it number 4, but don't. This is where I say it's the end of the video. Write down this classwork, and you will get this done tomorrow.